In 1961, humans traveled into space. This marked the beginning of the space age. Since then, space development focused on finding methods of transporting humans into space and researching space exploration technology. Just 60 years later, the International Space Station flies through space at an altitude of 400 kilometers above our heads, rotating around the entire Earth in just 90 minutes. On board, the Japanese experiment module Kibo continues to separate itself from traditional space development. We are moving from an era of learning about the universe into an era of using the universe. By taking on new challenges, Kibo continues to push the boundaries of its human space activities. Let's take a look back on some of the accomplishments from 2018, a year that became a new benchmark for Japanese space development. In 2018 marked the 10th anniversary of Japan's experiment module Kibo being placed on the International Space Station. Being Asia's only country participating in the ISS program, Kibo is both at the forefront of space development and is giving Japan the ability to show the world what it's capable of. Kibo is one of 4 experiment modules on the ISS. The module contains an onboard laboratory, onboard storage room, and off-board experiment platform. Kibo's activities on the ISS have led to numerous positive discoveries and results. The possibility of creating new medicine. We are moving from an era of applying science to learn about space to an era of applying science in space. Kibo aims to realize a society of healthy longevity through experimenting in space, an environment that surpasses logic on Earth. There's virtually no gravity in space. Research in such environment has led to the conclusion that if astronauts do not exercise in space, they experience symptoms similar to aging. JAXA and a research team from Tohoku University's Tohoku Medical Megabank Organization conducted a mouse breeding mission on Kibo that lasted for 31 days, from April 4th to May 5th, 2018. The experiment was to test what kind of effects outer space environments can have on mammals. This was the first time genetically engineered mice were bred and raised in space, and successfully made it back to Earth alive. The detailed results were made available to international researchers for societal benefit. The data doesn't only allow for a deeper understanding of the aging process. The science world is also buzzing about potential applications that could help realize a world of longevity and health by finding solutions to problems that come from our aging and high-stress society, like cancer and osteoporosis. In space, gravity, temperature, and the level of radioactive rays act nothing like they do on Earth. This is why there is much that can be done in space, and much that can be learned. In addition to its onboard laboratory, Japan's experiment module Kibo also has an off-board experiment platform. There are 2 main jobs for the off-board experiment platform, located on the outside of the ISS. One is to launch microsatellites into space, using an airlock and robotic arm. This technology is something only Kibo is capable of. Timing is incredibly important when it comes to launching microsatellites, and using Kibo allows satellites to be launched at will without affecting rocket launch schedules. JAXA has made the microsatellite launching ability of the off-board experiment platform available for use, primarily for countries that don't yet have the ability to launch rockets. Working with overseas institutions and international groups, Kibo continues to spread knowledge and experience garnered from space development to the younger generation worldwide. Across May 11th, August 10th, and October 6, 2018, Kibo launched a total of 9 microsatellites into space, all of which were created by research groups and universities. These microsatellites are aimed to collect weather data, take footage of the Earth, as well as other useful applications. In addition to launching microsatellites, the off-board experiment platform is also used for special experiments in outer space. The environment outside the ISS is filled with high-energy space rays and is very dangerous, and all materials used on the ISS must be able to withstand this harsh environment. Testing materials are placed on the off-board experiment platform using Kibo's airlock and robotic arm. Materials are exposed to outer space for a set amount of time. There are 2 methods used for these experiments. One is to place test materials on the Exposed Experiment Handrail Attachment Mechanism, XHAM, for long-term space exposure. JAXA has made this type of experiment available for international use. In Malaysia on November 2, 2018, test samples for a material test requested by University Putra Malaysia were returned to the country. In addition to XHAM, experiments can also use the Small Exposed Experiment Platform, ICEP. Since ICEP can provide power and communication, it can implement a sensor to be active at certain intervals, making it possible to hold experiments that use cameras and relay information in ways that XHAM isn't capable of. In addition to international groups, JAXA is expanding access to Kibo's valuable functions for use in the business world as well. The universe, which at once was a complete mystery, is now an environment that allows for various business opportunities. With a market value of nearly 3.8 billion yen, private businesses have been excitedly waiting for opportunities to expand into space. 2018 marked the beginning of a new generation of space business. In 2018, JAXA made the Off-Board Experiment Platform Adapter, ICEP, available for private use. Place a camera in outer space and create a business of selling 4K space videos. JAXA and Amana Images began selling images of Japan taken by the camera on ICEP on September 13, 2018. Until then, videos related to the ISS were rarely used for commercial business. Kibo was able to surpass its original purpose as an experiment module and create brand new potential for space business. Microsatellite deployment also reached the hands of the public. JAXA opened up its ability to launch microsatellites to private businesses, allowing them to expand into the space business. With launch requirements now easier to meet, launching microsatellites became a viable business option, and a number of private companies have already created departments dedicated to the microsatellite launching business. We expect the demand to use Kibo's off-board platform for business opportunities to increase exponentially in the future. Conducting space experiments in space. Over 10 years, Kibo has continued to benefit the development of space science, and there is no end to its activity. Through improvement, Kibo will continue to lead the way for space science. In March 2018, the XHAM Development Operation Team was recognized for their efforts on furthering Japan's space engineering capabilities and received the Space Frontier Award of Space Engineering Division by the Japan Society of Mechanical Engineers. Then in April, JAXA won MEC's Prize for Science and Technology for their effort on the Small Satellite Orbital Deployer platform. JAXA's effort has resonated with scientists and researchers around the world. In September, a dissertation about research data collected by Khalet's science team over 2 years was featured in a US science magazine. Khalet is an international collaboration between Japan, Italy, and the US that uses Kibo's off-board experiment platform. The goal is to discover where high-speed space rays, like gamma rays, originated from. Findings from this experiment may help us understand the origin of our universe and answer other questions we still have about space. Scientists around the world have lauded the research results. Furthermore, a research paper discussing the results of 200 days of observing an X-ray nova found by the Monitor of All-Sky X-ray Image, MAXI, was published on the online version of Publications of the Astronomical Society of Japan. The MAXI apparatus on Kibo's off-board experiment platform offers the world's largest field of vision. What kind of things are happening in deep space, far, far off from the galaxy we reside in? With MAXI, we may be able to answer some of the riddles the ever-expanding universe presents to us. In 2018, JAXA made numerous accomplishments. Like pieces of a jigsaw puzzle, those accomplishments come together to give us a better view of the future of space development. From Earth's orbit to the Moon and on to Mars, JAXA's aim is to reach farther and farther into the universe. The future has already begun. 2018 also marked the 10th anniversary of the ISS supply module HTV, also known as KOUNTORI. Currently in its 7th reiteration, Japan's HTV is the world's largest unmanned supply module with a capacity of 6 tons. It is used to transport goods directly to the ISS. This made it possible to resupply the ISS with daily necessities for life in space, large equipment, and project materials. With its unprecedented 100% mission success rate, HTV helps keep the ISS operating smoothly. This time, a new mission was given to HTV-7. After completing its job on the ISS, its mission was to retrieve small return capsules containing protein crystals made on Kibo and bring the capsules back to Earth. This would mark the first time Japan would attempt to retrieve materials from the ISS. To achieve this, they used a familiar technology, the thermos bottle. Although the face of the capsule will experience 2,000-degree heat once it pierces the Earth's atmosphere, the test sample inside the capsule will remain at a temperature of 4 degrees Celsius, so the contents can reach the Earth safely. The capsule was recovered in the sea nearby Japan. On November 27, 2018, JAXA held a press conference at the Tsukuba Space Center to explain the results of the small capsule technology demonstration. This was the first accomplishment of its kind, with JAXA's engineers teaming up with private businesses, marking a big step towards the next phase of space development. In the near future, this new challenge is expected to greatly benefit human activity in space. Of course, JAXA also has its eyes set on the future of space development through other endeavors as well. Controlling heat in space is incredibly important because outer space has no atmosphere, therefore making it difficult for heat to transfer. If you were to power up an apparatus packed with mechanical instruments without a method of releasing heat, it would overheat in an instant. As a solution to that problem, LHP, a loop heat pipe radiator that allows for effective heat control in outer space, was delivered for technological demonstration at Kibo. It underwent about 1 month of technical checks and tests in space. This technology will be tested with the 9th Engineering Test Satellite, marking Japan's first steps into next-generation geostationary communications satellites and space probes. JAXA has also begun creating a system for human resource development and education. The microsatellite deployment is one of the results of that effort. At the Asian Tri-Zero-G 2018, held on February 13, 2018, more than 360 students, engineers, and researchers from across Asia submitted over 160 experiment proposals, 8 of which were chosen to be sent up to Kibo on the ISS, where Japanese astronaut Norishige Kanai engaged in the experiments. After the experiments concluded, educational events, exhibitions, and awards were held across the continent of Asia. As numerous companies are aiming to create JAXA-certified Japanese space food, young high school students in Fukui Prefecture took on the challenge of developing canned mackerel seasoned with soy sauce. The final product was a hit with the astronauts. Perhaps this JAXA-certified Japanese space treat will be sent up to the astronauts in the ISS someday soon. Through activities like these, JAXA aims to spread the excitement of space development to the younger generation, inform them about the importance of what Kibo is doing in space, and, hopefully, create the next generation of scientists to help carry Japan's space development into the future. Wouldn't it be great to implement astronaut training into a class at school? JAXA began JSpark, a space innovation partnership between JAXA and private businesses to promote the future of space research and development. In June 28, 2018, the JSpark briefing featured a total of 38 proposals from 28 companies. Travel into space. Venture out onto the moon and other planets. Deploy your own satellite. These goals are no longer science fiction. Japanese astronauts playing a major role in space. what was once a dream is now a reality, and it has even become possible for people on Earth to communicate directly with the scientists on the ISS. And the expectations for Japan's astronauts only continue to grow. Near the end of 2019, astronaut Soichi Noguchi will be embarking on his third long-term stay on the ISS.
リレーは4人でやるものですから、金井さんに続いて第4、ランナーとしてですね、最終ランナーとしてこの2010年代の、日本の有人宇宙飛行を、最後まで駆け抜けていきたいなという気持ちです。
Similarly, it was announced that Akihiko Hoshide will be embarking on ISS exhibitions 64 and 65, and that he would be named commander of the ISS during exhibition 65.
やはり将来の宇宙探査に向けて今後、いろいろな技術実証ですね、そういったことも行ってくることになると思いますので、そういったところに参加できればいいなというふうに思っております。
Kibo leads Japan's space development aspirations, and JAXA will continue to find new ways to implement it. All of our work at JAXA is to find ways to take our expectations of space further and fill the future leaders of space development with dreams of what can be possible.